Montana, late October 1947. The most respected builder in Flathead County stood in front of what looked like half a metal barrel lying on its side, shook his head, and said it was the stupidest shelter he'd ever seen in 30 years of construction. He wasn't alone. By November, the entire valley was talking about the war veteran who'd lost his mind building a tin can instead of a proper log cabin. They called it everything from a grain silo to a steel coffin. Some laughed. Others felt genuine pity. But when January's cold front dropped temperatures to 40 below zero, something impossible happened inside that curved metal shell. 67 degrees warmer. Today you'll understand why the worst idea became the most copied design in 3 Montana valleys, and how a structure everyone mocked outperformed every traditional cabin when survival became the only measure that mattered. Subscribe now to get a real survival technique every week that worked when life depended on it. Hit that like button and drop a comment telling us where you're watching from, because this story proves that the best solutions often come from the most unexpected places. Raymond Caldwell returned to Montana in the spring of 1947 with a duffel bag, a military pension, and plans to disappear into the wilderness he'd grown up in. He'd spent 3 years in the Aleutian Islands as a CB construction engineer, building structures that had to withstand winds that could peel corrugated steel like paper and cold that turned diesel fuel to sludge. The valley hadn't changed. Same families, same methods, same cabins, and the same brutal winters that consumed stacks of firewood taller than a man. Raymond bought 20 acres near the Whitefish Range, 4 miles from the nearest neighbor. He had enough pension to buy materials, but not enough to waste on inefficiency. He'd watched too many Montana families burn through 8 cords of wood each winter, feeding drafty cabins that leaked heat through every corner joint and floor gap. The standard method everyone followed was simple: notched logs, chinked with moss and clay, stone fireplace on one end, wooden floor raised on posts, steep roof to shed snow. It looked right. It felt traditional. It had been built the same way for 100 years. It was also thermally catastrophic. Raymond had measured temperatures in traditional cabins during his teenage winters. 72 degrees near the fire, 48 degrees in the corners, 35 degrees at floor level. The heat rose straight up and out through the roof, while cold air poured in through the floorboards. Every log junction was a thermal bridge bleeding warmth into the night. The fireplace itself was a heat vampire, pulling more warm air up the chimney than it radiated into the room. He'd seen men work themselves into early graves, just keeping their families from freezing. Raymond decided to break every rule the valley respected. In June, a flatbed truck delivered something that made people stop and stare: a surplus Navy Quonset hut. 20 feet long, 13 feet wide at the base, curved metal ribs covered in corrugated steel. The kind of structure the military threw up in hours for equipment storage or temporary housing in the Pacific Theater. Not a log in sight. The neighbors who saw it assumed Raymond was building a workshop or a storage shed. When word spread that he planned to live in it through the winter, the confusion turned to concern, then mockery. "That's not a cabin," one trapper said at the general store in Columbia Falls. "That's a culvert pipe with a door." But Raymond understood something the traditional builders missed. The Quonset's curved shape eliminated corners where cold air pooled. The continuous arch meant no ridgeline, no peak, no place for heat to gather and escape. Every square inch of interior surface was equidistant from the center, creating a natural convection loop. And most importantly, there were no thermal bridges, no log junctions conducting heat straight through to the outside. The shape itself was a heat trap. He dug his foundation 18 inches deep in a clay hardpan, poured a concrete floor with embedded river stones for thermal mass, and bermed earth 3 feet up the sides of the Quonset. The curved metal shell became a skeleton. Over it, he laid 2 inches of cork insulation salvaged from a demolished ice house in Kalispell, then covered everything with a second skin of overlapping cedar shakes. The result looked strange. Organic and industrial at the same time, like a beaver lodge built by an engineer. People didn't know what to make of it. Raymond didn't care what it looked like. He cared that the physics worked. Curved surfaces for convection. thermal mass in the floor to store heat, earth berming to stabilize ground temperature, cork insulation to prevent conduction loss, and a small, efficient rocket stove in the center instead of a massive stone fireplace that would waste half its heat up a chimney. It made perfect sense to him. To everyone else, it looked like a man who'd spent too long in the Aleutians had forgotten how to build for Montana. The Quonset sat on Raymond's land like a question mark in 3 dimensions. By August, the structure was weathertight. The curved shell was insulated, the floor was cured, the door was hung. Raymond installed 4 small windows on the south-facing side, each one strategically placed to capture low winter sun. He built a vestibule entrance, creating an airlock that prevented cold air from rushing in every time the door opened. Inside, the space was surprisingly generous. The arch gave 7 feet of headroom down the center line, tapering to 4 feet at the walls. He built a sleeping loft at one end, suspended from the ribs, which put him in the warmest layer of air at night. Storage ran along both curved walls, and in the center, exactly where the geometry focused heat most efficiently, sat his rocket stove. Not a fireplace, a rocket stove. This is what made the experts furious. A rocket stove is a J-shaped combustion chamber that burns wood so efficiently it produces almost no smoke. Air enters at the base, flows up through the fuel, and creates a self-sustaining draft that burns wood at temperatures high enough to consume the smoke itself. The exhaust gases travel horizontally through a thermal mass bench before exiting through a small chimney. Raymond built his from fire brick and clay, with a combustion chamber 8 inches in diameter and a thermal mass bench that ran 6 feet along the north wall. The bench was filled with river stones and capped with flagstone. It absorbed heat during the burn and radiated it for hours after the fire died. The entire system used 1/5 the wood of a traditional fireplace and put 4 times the heat into the room instead of up the chimney. When Marcus Hendren, the most experienced builder in Flathead County, came to see what Raymond was doing, he stood in the doorway for a long time without saying anything. Then he spoke. "This is the dumbest thing I've ever seen a sane man build." Hendren had 40 years of construction experience. He'd built 17 cabins in the Flathead Valley alone, each one a testament to traditional log craftsmanship. He'd learned from his father, who'd learned from homesteaders in the 1880s. He knew what worked, and this wasn't it. Metal conducts cold, Hendren said, rapping his knuckles on the Quonset's interior wall. You're living inside a giant heat sink. First hard frost, this thing will be an icebox. Raymond tried to explain the insulation layers, the thermal mass floor, the convection advantage of the curved ceiling. Hendren cut him off. Insulation don't matter when you're wrapped in tin. And that toy stove. He gestured at the rocket stove. You'll freeze to death waiting for that thing to heat this space. A real cabin needs a real fireplace. Stone. Massachusetts something that holds heat. The bench holds heat, Raymond said quietly. 600 pounds of stone. Hendren laughed. It wasn't cruel, just dismissive. The laugh of a man who'd seen young fools ignore wisdom before. Son, I've built in this valley since before you were born. Metal and winter don't mix. This isn't the Pacific. This is Montana. 40 below will find every weakness in that design, and there's a lot of weakness. He left shaking his head. By September, Hendren's assessment had spread through every logging camp, trading post, and church gathering in 3 valleys. The story grew with each telling. Raymond Caldwell, the war veteran, had built himself a metal coffin. He was going to learn the hard way that modern military ideas don't work in the Montana wilderness. Some people felt sorry for him. Others figured natural selection would handle it. A few called it arrogance. Real men build log cabins, one sawmill operator said. That curved tin shed is what happens when someone thinks they're smarter than 100 years of proven methods. The judgment wasn't just technical. It was cultural. Log cabins were part of Montana identity. They represented self-reliance, tradition, connection to the land. A Quonset hut represented factories, military bureaucracy, mass production. It didn't belong in the wilderness. It wasn't earned through the hard work of felling trees and notching logs. It was ordered from a catalog and bolted together. It didn't feel like home. It felt like surrender. Raymond kept working. He installed ventilation ports at the peak to prevent condensation. He built a drainage system around the foundation to channel snow melt away from the structure. He stockpiled 2 cords of seasoned larch, which he calculated would last the entire winter with a rocket stove's efficiency. His neighbors stockpiled 8 cords each. When the first snow fell in October, people stopped talking about Raymond's Quonset. There were more important things to worry about. Wood to split, chinking to repair, supplies to stock. Winter was coming, and winter didn't care about anyone's theory. The real confrontation happened in November at the monthly community gathering at the Columbia Falls Grange Hall. Raymond rarely attended these meetings, but he needed to arrange a supply run before the heavy snows closed the valley roads. He sat in the back while the community discussed winter preparations, road maintenance, and a debate about whether to pool resources for a new sawmill blade. Then Marcus Hendren stood up. "Before we close," Hendren said, his voice carrying the weight of authority earned through decades of respect, "I want to address something that's been on my mind. We've got a situation that could turn into a tragedy, and I think we have a responsibility to speak up." Everyone turned to look. Raymond Caldwell is planning to winter in that metal structure up near Whitefish Range. I've seen it. I've inspected it. And I'm telling you right now, as someone who's built through 40 Montana winters, that shelter is not safe. The room went quiet. "That tin can will freeze him solid before Christmas," Hendren continued. "Metal conducts cold faster than anything. He's got maybe 2 inches of insulation between him and the night air, and he's planning to heat it with a stove the size of a milk can. It's not enough. Not for 40 below. Not for the wind we get up there." An older trapper named Douglas Mackey spoke up. "What's he supposed to do now? Tear it down and build proper?" "I'm saying we need to convince him to winter in town, or at least have a backup plan. I've offered to let him use my old line cabin up Henderson Creek. It's small, but it's solid log construction with a real fireplace. I'd rather see him safe than stubborn." Heads nodded around the room. Hendren looked directly at Raymond. "This isn't personal. You did good work in the service, and I respect that. But war experience don't translate to wilderness survival. That curved shed might have worked in the Pacific, but this is Montana. Different animal entirely." Raymond stood up slowly. "I appreciate the concern," he said, "but the structure is sound. The physics are solid, and I'll be fine." "Physics," Hendren said the word like it tasted bad. "Son, physics don't split wood at 3 in the morning when your fire dies and the temperature's dropping. Physics don't keep your water from freezing. Physics is something engineers talk about in heated offices." A few men chuckled. "That rocket stove is a novelty," Hendren continued. "I've seen pictures of them in magazines. They're fine for demonstration, maybe for a hunting camp in October. But you can't heat a winter shelter with something that burns twigs. You need mass. You need a firebox that can hold a full night's worth of logs. You need stone that radiates heat for hours." "The thermal bench is stone," Raymond said. 600 pounds of river rock. It holds heat for 18 hours after the fire goes out. "You've tested that?" Hendren's voice sharpened. "In January? At 40 below with a 30-mile-an-hour wind." Raymond paused. "Not yet. Exactly. You're betting your life on theory. I'm offering you 40 years of proven results." Another builder, a younger man named Carl Thorson who'd apprenticed under Hendren, stood up. "I saw that thing too. It's not just the metal. The whole design is wrong. You can't fight winter with curves and clever tricks. You fight it with mass, thickness, and traditional methods that kept people alive since before we had words like thermal mass. A real cabin," Thorson continued, "has corners, has weight, has logs 2 feet thick that don't care what the wind does because they're solid all the way through. That Quonset is just skin and air. First real cold snap will prove it." The criticism wasn't just about construction anymore. It had become about identity. "My grandfather built our family cabin in 1889, an older woman named Ruth Kerner said softly. "Survived winters that killed livestock and froze wells solid. That cabin is still standing because it was built right. Built with respect for what winter can do. That metal shelter, it just seems like disrespect. Like thinking you're smarter than everyone who came before." Raymond felt the room turn. This wasn't about engineering anymore. It was about belonging. about whether modern ideas could replace traditional wisdom, about whether someone who'd been gone 3 years still understood Montana. "I'm not disrespecting anything," Raymond said. "I'm using what I learned to build something efficient. That's all." Hendren's voice softened, but his words didn't. Efficiency don't mean survival. That's what you haven't learned yet. Winter out here isn't a problem you solve with clever design. It's a force you endure with proven methods. And that structure, son, is not proven. He paused, then delivered the line that would echo through the valley all winter. "That's not a shelter. That's a physics experiment with your life as the test subject. And I've seen enough winters to know how that experiment ends." The meeting moved on to other business. Raymond sat down and didn't speak again. Outside, after the meeting, a few people approached him with genuine concern. Offers of backup shelter. Invitations to stay with families if things got bad. One older trapper even offered to check on him weekly once the snow got deep. But underneath the concern was assumption. They believed Marcus Hendren. They believed 40 years of experience over 3 years of military engineering. They believed that when the real cold came, Raymond would either abandon his metal shed or pay the price for arrogance. By the first week of December, the story had spread beyond Flathead County. The veteran who thought he could outsmart Montana winter with a tin can and a toy stove. It became a cautionary tale before it even had an ending. People weren't laughing anymore. They were waiting for tragedy. January 1948 started quiet. Cold but manageable. Teens during the day, single digits at night. Raymond's Quonset performed exactly as he'd calculated. The rocket stove burned for 2 hours each morning and 3 hours each evening, bringing the interior to a steady 58 degrees. The thermal bench radiated gentle heat through the night, keeping the temperature from dropping below 45 even when the outside air hit zero. He used half a cord of wood in 3 weeks. His nearest neighbor, Frank Peterson, had burned through a cord and a half in the same period, feeding a massive stone fireplace that consumed logs like a foundry. But January wasn't done. On the morning of January 19th, the sky took on a color Raymond had only seen once before, during a freak storm in the Aleutians. Pale gray-green, like old ice. The air felt dense, compressed, as if something enormous was pressing down from above. The radio in town reported a cold front pushing south from Alberta. Arctic air, they said. Temperatures dropping fast. By noon, it was 8 degrees. By sunset, it was -12. By midnight, -28. And it kept falling. The wind arrived around 2 in the morning. Not the gusty, variable wind of a normal storm, but sustained 40-mile-an-hour push from the north that didn't stop. It found every gap, every weakness, every place where warm air met cold. In traditional cabins, it screamed through floor gaps and around window frames, creating drafts that made candle flames dance sideways. Raymond woke to the sound of wind testing his Quonset's curves. But the curved surface deflected it, sent it flowing over and around instead of battering straight on. No corners to catch. No flat faces to push against. He checked the thermometer mounted inside the door. 52 degrees. He hadn't added wood to the rocket stove since 9 the previous evening. The thermal bench was still radiating stored heat, doing exactly what 600 pounds of stone does when you heat it properly, giving back slowly, steadily, for hours. Outside, the thermometer read -37 degrees. 89-degree difference. And the temperature was still dropping. By dawn on January 20th, the official measurement at the weather station in Kalispell read -42 degrees Fahrenheit. With wind chill, it felt like -70. This was the cold that killed livestock in barns, that froze diesel fuel solid, that turned exposed skin white in under a minute. This was the cold that made old-timers tell stories about the winter of 1886, when cattle froze standing up and entire homesteads went silent. Raymond lit the rocket stove at 6 in the morning. It took 20 minutes to bring the Quonset's interior to 61 degrees. He used 3 pieces of wood. For miles away, Frank Peterson had been feeding his fireplace since 4 in the morning and couldn't get his cabin above 53 degrees. The corners near the floor were 38 degrees. Ice was forming on the inside of the windows. His children slept in the loft, huddled under every blanket they owned, fully dressed. He'd burned through 2 days' worth of wood in one night. The same scene played out across the valley. Families rationing firewood, calculating whether they had enough to last if the cold snap stretched to a week. People wearing coats indoors, sleeping in shifts to keep fires going, watching their carefully stockpiled wood shrink faster than expected. Marcus Hendren's cabin was better insulated than most, built with his 40 years of expertise. His fireplace was properly sized, his chinking was tight, his floor was raised and insulated underneath. It held 57 degrees with constant feeding. He'd burned through a quarter cord in 2 days. On January 22nd, Douglas Mackey, the old trapper who'd spoken up at the Grange meeting, decided to check on Raymond. He'd promised himself he would, and the cold snap seemed like the time to make good on it. If the kid was in trouble, now's when it would show. He snowshoed the 4 miles to Raymond's property, arriving just after noon. The Quonset sat in its clearing, snow-covered, almost invisible against the landscape except for the thin stream of smoke from the small chimney. Mackey knocked, expecting to find Raymond huddled near the stove, burning through his wood supply in desperation. Raymond opened the door in a wool shirt and suspenders. No coat. Warm air rolled out of the Quonset like a physical thing. "Douglas," Raymond said. "Come in. Coffee's hot." Mackey stepped inside and stopped. The interior was warm. Actually warm. Comfortable. The kind of warm where you didn't think about cold anymore. "What's your temperature in here?" Mackey asked. Raymond pointed to the thermometer. 64 degrees. It's been between 61 and 67 since the cold front hit. Mackey stared at the rocket stove. A small fire burned in the combustion chamber, no larger than what you'd use to heat a pot of soup. The thermal bench radiated gentle heat you could feel from 6 feet away. "How much wood are you burning?" "About 1/5 of a cord every 3 days. Same rate as November." Mackey did the math in his head. He was burning a cord every 5 days. Raymond was burning a cord every 15 days. And Raymond's cabin was warmer. "The Hendren place is barely holding 57, Mackey said quietly. "Frank Peterson's kids are sleeping in coats, and you're in here in shirt sleeves." "The design works," Raymond said. "The curves eliminate cold spots. The thermal mass holds heat. The rocket stove delivers efficiency. It's all physics." Mackey sat down on the thermal bench. The warmth soaked into him like a hot bath. "Marcus needs to see this," he said. "He won't believe it," Raymond replied. "He will when I bring a thermometer. Stay with me because the result humiliated the correct method and turned 40 years of traditional wisdom upside down." Hit that like button, subscribe for more survival techniques that actually worked when it mattered most, and drop a comment telling us where you're watching from. Douglas Mackey returned to town with numbers that didn't make sense. 64 degrees inside the Quonset, minus 42 degrees outside, 106-degree difference. And Raymond wasn't even burning wood constantly. The fire had been out for 3 hours when Mackey arrived, and the temperature had only dropped 2 degrees. He told Marcus Hendren first, figuring the master builder deserved to hear it directly. Hendren didn't believe it. "Impossible," he said flatly. "Metal conducts cold. There's no way that structure is holding those temperatures with that little fire." "Come see for yourself," Mackey said. "Bring a thermometer. Bring whoever you want. But that Quonset is warmer than any cabin in this valley, and it's using a fraction of the wood." Hendren went the next morning, January 23rd, with Carl Thorson and 2 other experienced builders. They brought 3 thermometers, a notebook, and the certainty that Mackey had either been fooled or was exaggerating. Raymond welcomed them in. The thermometers all read the same, 63 degrees. Outside, minus 39 degrees. 102-degree difference. Hendren walked the interior slowly, checking for tricks. He felt the walls. The insulation was real. He examined the rocket stove. Small, efficient, burning clean with almost no smoke. He sat on the thermal bench, warm to the touch, radiating steady heat hours after the last burn. He checked the corners. No cold spots. The curved ceiling created a natural convection current that distributed heat evenly. Warm air rose to the peak, cooled slightly, and descended along the walls, creating a gentle circulation that prevented stratification. "How much wood did you burn yesterday?" Hendren asked. Raymond showed him the wood stack. 11 pieces. About 1/8 of what you'd feed a traditional fireplace. Thorson was examining the rocket stove's design. "This thing burns hotter than a regular fire?" "Cleaner," Raymond said. The J shape creates a draft that pulls air through the fuel at high velocity. Burns wood at around 1400 degrees instead of the 800 you get in an open fireplace. Hot enough to consume the smoke. Almost complete combustion. "And the heat goes where?" Hendren asked, though he could already see the answer. "Into the thermal mass bench. 600 pounds of river stone. Absorbs heat during the 2-hour burn. Releases it slowly over the next 18 to 20 hours. It's like a battery that charges fast and discharges slow." Hendren sat down heavily on Raymond's handmade chair. 40 years of experience had just been contradicted by a curved metal shed and a stove that looked like a clay toy. "The wood consumption," Hendren said slowly. "If you're burning 1/5 what we are and staying warmer, you're getting about 20% efficiency from your fireplace," Raymond said. "Most of the heat goes straight up the chimney. I'm getting close to 80% efficiency. The exhaust barely has enough heat to create draft by the time it leaves the chimney." The numbers were devastating. Over the next week, as the cold snap continued, word spread. People started measuring, comparing, tracking wood consumption and interior temperatures. The results were consistent and humiliating to traditional methods. Raymond's Quonset, interior temperature, 61 to 67 degrees Fahrenheit during peak cold wood consumption. 1/5 cord per week burn time. 5 hours per day, 2 morning, 3 evening. Temperature drop overnight. 3 to 5 degrees Fahrenheit cold spots. None measured draft problems. 0 Marcus Hendren's cabin. Best traditional construction interior temperature. 54 to 58 degrees Fahrenheit during peak cold wood consumption. 1 cord per week burn time. 18 hours per day. Constant feeding. Temperature. Drop overnight. 12 to 15 degrees Fahrenheit if fire died cold spots. 15 to 20 degrees Fahrenheit colder in corners draft problems. Frequent, especially during wind. Frank Peterson's cabin. Typical construction interior temperature. 48 to 53 degrees Fahrenheit during peak cold wood consumption. 1.2 cords per week burn time. 20 plus hours per day temperature drop overnight. 18 to 22 degrees Fahrenheit if fire died cold spots. 20 to 25 degrees Fahrenheit colder at floor level draft problems. Constant, children sleeping in coats. The most shocking measurement came on January 28th, when the temperature hit minus 44 degrees Fahrenheit with sustained winds of 35 miles per hour. Raymond's Quonset maintained 67 degrees inside. Peterson's cabin, with the fireplace roaring and consuming wood as fast as it could be fed, struggled to reach 51 degrees. 67 degrees inside a metal structure that experts said would freeze solid, versus 51 degrees inside a traditional log cabin burning 5 times the wood. The math was brutal. The physics was undeniable. But more than temperature, it was the quality of life difference that struck people hardest. In Raymond's Quonset, you could sleep without layers. You could wake up without your breath fogging. You could walk barefoot on the concrete floor without your feet going numb. You could cook, read, work on equipment without fighting constant cold. In traditional cabins, even the best ones, winter was endured. You lived close to the fire, wore multiple layers indoors, and accepted that cold was part of survival. You rationed wood carefully because running out meant potential death. You woke multiple times each night to feed the fire, because letting it die meant waking to freezing conditions. Raymond woke once each night, not to feed the fire, but out of habit from the military. The fire had been out for hours. The temperature had dropped 3 degrees. He went back to sleep comfortable. On February 2nd, Douglas Mackey did the math that would become legendary in 3 valleys. That Quonset used 0.8 cords of wood from January 19th through February 1st. 14 days of the worst cold we've had in 20 years. 0.8 cords. He looked around at the men gathered at the general store. I used 4.2 cords in the same period. Marcus used 3.8. Frank used 5.1. Someone did the calculation. Raymond used 84% less wood than Frank. And stayed warmer, Mackie added. 16 degrees warmer on average. 23 degrees warmer during peak cold. The silence in the store lasted a long time. That's not possible, someone finally said. But it was a weak protest. The numbers were too consistent. Too many people had measured. Too many thermometers had confirmed. It wasn't theory anymore. It was empirical fact. Marcus Hendren, to his credit, didn't make excuses. He went back to Raymond's Quonset 3 more times, studying every detail, taking notes, asking questions. He measured the thermal bench's cooling curve over 24 hours. He observed the rocket stove's burn pattern. He traced the convection currents with smoke from his pipe. On his last visit, he said something that showed the character that had earned him 40 years of respect. I was wrong. About the metal. About the design. About the physics. I built the way I was taught, and it worked well enough that I never questioned whether it could work better. You questioned everything, and you found answers I didn't know existed. You paused at the door. That's not stubbornness. That's engineering. And I'm sorry I called it stupid. Raymond shook his hand. You weren't wrong to be skeptical. You were protecting what you knew worked. I just found something that worked better. The cold snap broke on February 7th, 1948. Temperatures climbed to a balmy 15 degrees. People emerged from their cabins, assessed their wood supplies, and began calculating whether they'd make it to spring without running out. Raymond had a cord and a half remaining. More than enough. Frank Peterson had less than half a cord left, with 6 weeks of winter still ahead. He wasn't alone. Across the valley, families were rationing, sharing, cutting green without a desperation. The Quonset had proven itself in the most brutal test Montana could deliver. 67 degrees warmer than some cabins during peak cold. 84% less wood consumption. 0 draft problems. 0 cold spots. 0 nights waking to feed a dying fire. The stupidest shelter anyone had ever seen had just redefined what was possible. Spring came late to the Flathead Valley in 1948, but when it arrived, something had fundamentally changed. Marcus Hendren showed up at Raymond's property in late March with a proposition. I've got a client in Eureka who wants a cabin built. Young couple, limited budget, but they need something that'll handle winter. I told them I'd build a traditional, but I'm recommending they talk to you first. It was more than a referral. It was an acknowledgement. I'm still going to build log cabins, Hendren continued. There's beauty in traditional methods, and people value that. But for pure survival efficiency, for people who need to maximize warmth and minimize wood consumption, what you've built here is superior. I won't deny that anymore. The young couple visited in April. They chose a modified Quonset design. By May, 3 more families had contacted Raymond. By June, he had requests for 7 structures. The spread wasn't dramatic. It wasn't a revolution. It was quiet, practical adoption by people who'd learned the hard way that efficiency matters more than appearance when survival is at stake. Carl Thorson, who'd called the Quonset skin and air at the Grange meeting, built a hybrid structure for his brother-in-law. Traditional log walls with a curved metal roof and a rocket stove. It combined the aesthetic people wanted with the thermal performance they needed. Douglas Mackey added a thermal mass bench to his existing cabin, retrofitting the concept into a traditional structure. It didn't match the Quonset's efficiency, but it cut his wood consumption by 30%. Frank Peterson, who'd struggled hardest during the cold snap, became Raymond's biggest advocate. I'm not tearing down my cabin, he told people. But if I was building new, I'd do it Raymond's way. My kids were cold all winter. His place was comfortable. That's all that matters. By the winter of 1949 to 1950, 17 structures in the region incorporated elements of Raymond's design. Not all were Quonsets. Some were traditional cabins with thermal mass modifications. Some were hybrid designs. Some were straight copies of Raymond's curved metal shell. But they all shared the same principle. Engineer for efficiency, not tradition. The cultural resistance didn't disappear overnight. There were still old-timers who insisted that real Montana cabins had to be built from logs. There were still people who valued the aesthetic and tradition of notch timber construction. But after the winter of 1948, no one called Raymond's design stupid anymore. The numbers had silenced the mockery. What's remarkable isn't that Raymond built an efficient shelter. Humans have been solving thermal problems for thousands of years. What's remarkable is how completely traditional wisdom had calcified into assumed truth, and how resistant people were to questioning it even when the evidence was obvious. Marcus Hendren had 40 years of experience building structures that worked. They kept people alive. They were beautiful. They connected families to pioneer heritage. But works and optimal aren't the same thing. Raymond didn't disrespect traditional knowledge. He studied it, understood its principles, and asked a simple question: can this be better? The curved shape eliminated thermal bridges and cold spots. The rocket stove maximized combustion efficiency and heat transfer. The thermal mass bench stored energy for slow release. The earth berming stabilized ground temperature. The insulation prevented conduction loss. None of these concepts were new. Thermal mass had been used in European masonry stoves for centuries. Earth berming was ancient. Efficient combustion was understood by anyone who'd ever needed to cook with limited fuel. Raymond just combined them with modern materials and military engineering precision. The result was a structure that outperformed traditional methods by every measurable metric while using a fraction of the resources. That's not luck. That's not novelty. That's what happens when you respect the principles behind tradition without being enslaved to traditional methods. The Quonset itself stood for another 32 years. Raymond lived in it until 1964, when he built a larger home for his family. But he kept the original structure maintained, using it as a workshop and guest cabin. Visitors always commented on the same thing. Stepping inside felt like entering a different climate zone. Even with no fire burning, the thermal mass and insulation kept interior temperatures remarkably stable. In 1980, a University of Montana engineering student wrote his thesis on vernacular cold climate architecture in northwestern Montana. He documented 17 Quonset-style structures and 43 traditional cabins with thermal mass modifications, all traceable back to Raymond's 1947 design. The conclusion was simple. Caldwell's innovation reduced winter heating requirements by an average of 72% compared to contemporary traditional construction, while improving thermal comfort and reducing labor. The design's adoption rate correlates directly with exposure to empirical data during the 1948 cold snap. In other words, people believed the numbers when they couldn't deny them anymore. Raymond Caldwell passed away in 1993 at the age of 74. His obituary in the Flathead Courier mentioned his military service, his family, and his work as a contractor. But locals remembered something else. They remembered the winter when a war veteran proved that the stupidest shelter anyone had ever seen could be 67 degrees warmer than traditional cabins, using 1/5 the wood, because he understood that the best solutions often come from questioning everything everyone assumes is settled truth. He wasn't being stubborn. He was being practical. And sometimes, practical looks crazy until it proves itself undeniable. Which part of this solution would you apply to your home today? Drop a comment below and tell us where you're watching from. If you want more survival techniques that actually worked when life depended on it, hit that subscribe button and like this video. These stories prove that sometimes the wisdom of the past needs the engineering of the present to reveal what's truly possible. Educational note: this narrative is a historical dramatization based on documented principles of thermal mass, rocket stove efficiency, and vernacular architecture. Specific technical claims reflect period-appropriate engineering understanding. Any construction project should comply with current building codes and safety standards. This content is for educational and historical interest, not professional construction advice.